Researchers hope that advances in robotics and connected technologies could soon enable minuscule robots that are capable of traveling throughout the body to diagnose and treat medical conditions. Engineers are already able to build those types of tiny machines, but numerous hurdles still need to be overcome before they can become common practice. In addition to the engineering challenges inherent in creating a robot that could fit on the head of a pin, microrobots also face logistical challenges. Putting those systems together takes a lot of skill, patience, and time. At least 8 hours per microrobot, according to University of Toronto engineers. To help make that process considerably more efficient, Toronto engineers developed a method that builds a microrobot in as little as 20 minutes. By using a 3D printer, engineers were able to print out different robotic structures that included sections of magnetic material. They then applied magnetic fields to control how those sections could maneuver the robot through vessels, or close its tiny jaws entirely to collect a tissue sample. The significantly easier production process could autonomously provide microrobots on the scale needed for medical applications, as well as allow scientists to easily create different designs and even smaller devices, potentially as many as 10 times tinier than current millimeter-sized microrobots. I'm Andy Zoll, and this is IEN Now.